Good morning, Year 6. 2 videos in 2 days, you lucky things. 5th of February today. Now, yesterday's lesson we did a bit of area and perimeter again, and we did some shape. We're still going to look at some of those area and perimeter reasoning questions that you were looking at earlier this week. We're starting with a place value poser. Now, I don't mean poser as in all the Year 6 boys posing in front of the mirror. What I mean is a poser is in a question problem, so we're going to have a little look at some tasks linked to that. It'll be familiar, especially to my maths group. We've done it before. Then we're going to have a reasoning walkthrough, just like we did yesterday. That's what you'll be saying after you've heard some of the answers. And then, before we go on to talk about the assignment, we're going to have a little bit of what went wrong. Okay, so for our place value poser, this is a game that we've played before. Like I said, we're going to try and reach a target number by rolling a die. Remember, 1 die, 2 dice. If you don't say 1 dice, you say 1 die. If you've got 2, you say 2 dice. So, what we're going to do is we're going to roll the die, see what numbers we come up with, but I'm going to try and arrange those numbers so I get the greatest number possible. Alright, let's roll those numbers. 5. Now, this die goes from 1 to 6. Now 5, obviously one of the greater numbers on the die. 6 is the greatest, however, so if I'm wanting to make the greatest number possible, I'm going to place the 5 in the 10,000s column. Now there's a chance, obviously there's a chance that I could roll a 6 and the remaining goes. There's also a chance I could roll another 5. There's a chance that I could roll all lower numbers. So let's see if I place that correctly. Well, I'm going to be optimistic and I'm going to say I'm going to put the 4 in the hundreds column and hope that doesn't come back to bite me. Another 5 then. So the question is, do I put it in the 100,000s column? Do I put it in the thousands? You know what? I'm going to hold out for a 6. I'm going to put it in the thousands. So I need a 6. I also need some numbers, some digits less than 5. 4th roll now. Oh, what do you know? It's a 6. So that 6 is going straight in the 100,000s column. It's all looking good so far. As long as I can roll some lower digits for those final 2. Let's see. Come on. Oh, you beauty. It's a 1. Where are you going to go? You're going to go in the 1s column. Come on, I need a 1, a 2, a 3 or a 4. Let's see. Say a little prayer before this one. Oh, and it's a 4. The crowd goes absolutely bananas. So that 4 will go in the 10s column to complete my number. What do you know? How this doesn't happen very often. I mean, for all you know, I could have done 1,000 takes before getting it, but we've got, finally, we've arranged the digits actually in the correct place. So I've got 655,441. And that was the greatest number you could make with those digits. Okay, so I've got 2 grids set up here for greatest and smallest. So the first one we're going to try and make the greatest number possible, or rather you are. And then the second round we're going to try and aim for the smallest number possible. So I'm going to roll the die. I want you to pause in between each roll and put your digit in the place that you think it should go. And at the end I will reveal what the greatest number could have been and what the smallest number could have been. Let's go. First digit is a 2. Second digit is a 1. Third digit, a 1 again. 4th digit, 6 digit, a 3. And the final digit for the first round, it's a 5. So in order, there was 2, 1, 1, 6, 3, 5. But if you aim to make the greatest number from those digits, if you'd done it successfully, you would have had 653,211. You might have had a slightly different answer to that, depending on how you ordered your numbers. Right, round 2, smallest number. So this time you wanted to make the smallest number possible from the digits that come up. First digit, 5. Second digit, 3. Third digit, 1, fourth digit, a 2, a 3, and the final digit, 4. So those are the digits that were rolled, and to create the smallest number you would have had to have placed them in this order. 1, 2, 3, 3, 4, 5, which is 123,345. Well done if you predicted correctly. So that's our little place value game done for now. Remember, you can play that at home with one of your siblings, with a grown-up. All you need is one die, or you can get a random number generator or do some number cards. Just cut up pieces of paper, but you can challenge someone at home to see if you can beat them. So now we're going to take a look at the second thing. We're going to look at some more of the reasoning questions that you did on Tuesday and Wednesday's assignments. And very quickly, just before we go into those, here are some possible solutions for the shape puzzles task that you did in yesterday's assignment. Now, it's worth noting that for these final two, there is more than one solution possible. That is just one option that you could have chosen. Notice on some of them I haven't actually filled in the sides in terms of the shape, because, for example, if you had a four-sided shape, a quadrilateral, that would have given you lots of different options. You could have had a square, a rectangle, a rhombus, a parallelogram, a trapezium, a kite. Lots of different possibilities there. Okay, let's start with this question. Draw a rectangle on the grid that has half the area of the shaded triangle. Okay, there's two ways we can do this. We can first of all need to work out the area of the shaded triangle. And we can see that it is 4 centimetres on this measurement here, the base length, and the height is 6 centimetres. So if we want to work out the area, we need to do 6 times 4, which is 24, and then half it. Remember, it's half the base times the height. So half of 24 is 12 centimetres squared. Okay, and we want a rectangle that has that area. Sorry, half the area of that shaded triangle. And half the area of 12, we've halved that, and we can half it again. Half of 12 is 6 centimetres squared. Two different ways we could do that, because factors of 6 are 1, 6, 2, and 3. So we could draw one of those rectangles. I'll show you those now. So there are those possibilities. We could have 2 times 3. We could draw that in two different ways. We could have either a length of 3 and a width of 2, or a width of 3 and a length of 2. Same with 1 and 6. 1 times 6 equals 6 centimetres squared. We could also have drawn that vertically as well, if there was space on the grid. Now, another way we can prove that this triangle does have an area of 12 centimetres squared is if we can either do, you could literally do this with scissors if you had printed it off, but we can show by drawing on the diagram that it is 12 centimetres squared. Now imagine if I had cut the triangle here along that red line, the red dotted line, and if we then if we rotated that piece round and placed it here, it would look like this. Okay, so imagine that piece was cut off, rotated and placed on there. Now we can see that the area is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 centimetres squared. And again, because that would be a rectangle of 3 times 4. Okay, so we know, we can prove that the area will be 12 centimetres squared. And therefore, if a rectangle has half the area of the shaded triangle, that would be 6 centimetres squared. Okay, so if we've got a square that's 36 centimetres squared, it's a square number. 36 is a square number. And we know that squares have 4 identical sides, 4 sides the same length. And we know then that this must be 6 times 6 centimetres. All right? So all sides are 6 centimetres, because 6 times 6 is 36. So if the square is cut into quarters to create 4 identical rectangles, then that width is still going to be 6 centimetres. So they're all going to be 6 centimetres. But what we need to do is work out the length. So if they're 6 centimetres wide, now all of these added together make 6. So what's 6 divided by 4? Well, we can do that calculation here. Does 4 go into 6? Yes, it does. Once. We're going to go into the decimal places now. We're going to go into tenths with 2 carried over. Does 4 go into 20? Yes, it does. 5 times. So each of those is 1.5. Now, if you want to work out the perimeter of one of the small rectangles, we need to use these two measurements, but also recognise that if the width is 6 centimetres, then this side here will also be 6 centimetres. And if this side is 1.5, then this side will also be 1.5. Now, the perimeter is the distance around the outside of a shape. So what we need to do is add up those sides. 6 add 1.5, add 6 add 1.5. You might be able to do that in your head. You might want to do it like that. Okay, and the total will be 15. So the perimeter is 15 centimetres. Now a bit of a similar one here, because Chen has some right angled triangular tiles and the dimensions of those triangles are there. Okay, now the best thing to do with one of these questions is to start by annotating what you've got. So if his triangle has those dimensions, this is one of those triangles, so we can replicate those dimensions there. And then we can start to fill in some of the other details of the shape. If this height is 5 centimetres here, then this square must have all sides. And then we've got this identical triangle, so that length must be 13 centimetres, as is that. We've got another one of those squares, which must be 5 and 5, 13. Okay. And we are looking for the perimeter. So what we will do, add up all of those sides. It's really important to note that you do not add up the sides within the shape. Okay, so we're going to ignore that, we're going to ignore that. We're going to ignore all of these here. Because remember, perimeter is the distance around the outside of the shape. Now, we could add them all up using column addition. That would take longer. What we have is 4 lots of 5. 4 times 5 is 20. And we have 4 lots of 13. So we can do 4 times 13. You might be able to do that in your head. If you know 12 times 4, just add 4 more, and you will get 52. 3 times 4 is 12. 1 times 4 is 4, and 1 is carried over, so 52. We need the total, 52 add 20 equals 72 centimetres. Hope that helps with some of those questions, because I know that they were quite tricky and posing a bit of a problem for some. So remember, if there are questions that are causing difficulty, let us know and we can do a walkthrough on one of the later lessons. Okay, so there's the first 2 parts of the lesson ticked off. We're going to finish with some what went wrong. Okay, and that's going to help with your arithmetic test. So we're going to look at some arithmetic questions and see what went wrong with the way they were worked out. Okay, what went wrong? Question 1. Classic decimal addition. 25 at 6.3. What went wrong? Well, here's the working out. Pause the video. Can you explain what this person has done wrong? Right, the clue here is the decimal point. We've got a 2-digit number here, 25, with 10s and 1s. But all of a sudden we've got 6.3 placed beneath it. The 6 has been put in the 10s column, giving us an incorrect answer of 8.8. Really, we can look at that and say, Well, we started with 25 and we added more. So how have we got an answer that's a lot less? So we can tell that something has gone wrong. And if we look at this, this is how we should have set it out, because the 6's is now in the ones column. Our decimal point is in the correct place. So we can see that actually the answer would be 31.3. Much more realistic answer. Question 2. What went wrong? 15 take away 7.1. There's two versions here of what went wrong. We've got this first one. Right? 15 take away 7.1. Pause the video. See if you can tell me what this person has done wrong. Well, it's a familiar theme here, isn't it? Because we've got 15, which is tens and ones, but then we've got the 7 in the tens column, and the decimal point in the incorrect place. So this person has incorrectly set out their numbers again. What about this one? This is something I see quite often. People try it this way and then say, oh, that doesn't look right. Maybe I'll just put the numbers the other way around. I'll start with the 7.1. Take away 15. You get an answer of 56. At least I can do it without getting a negative number. Oops. What went wrong? Pause the video. See if you can explain. Well, I think it's clear to say what has gone wrong here, because they haven't put the numbers in the order that they are in the question. The question was 15 take away 7.1. This is 7.1 take away 15, and again the numbers are not placed correctly in the correct place value column. What they should have done is this. Put in a placeholder. So we'd have had 15.0 take away 7.1. We can't do 0 take away 1, so we've had to borrow from the ones. So we've made 10 take away 1, which is 9. Then we're left with 4 take away 7 in the ones column. Again, we can't do that, so we've had to borrow from the tens. We've regrouped that 10 into the ones, and we've done 14 take away 7. So the answer is 7.9. Final question of what went wrong, question 3. Fractions this time, 3/4 multiplied by 5. What went wrong with this working out? Well, we've multiplied the numerator and the denominator by 5. We've got 15/20. Can you tell me what went wrong? Pause the video. What this person has got confused with is multiplying fractions by a whole number with equivalent fractions. Now, with equivalent fractions, we use this method. We do the same to the top and the bottom. We multiply the numerator and the denominator by the same digit. However, that's just the same fraction. The fraction hasn't changed. Right? 3/4 is equal to 15/20. So we haven't done 5 lots of 3/4. What we should have used is this method here. We've done 3/4 times 5 over 1. Now remember, we can write a whole number like that, all right, with 1 as the denominator, because any integer, a whole number, can be written as a fraction with a denominator of 1. 4 would be 4 over 1, 3 would be 3 over 1, and 5 is of course 5 over 1. And now we can multiply this, because we can do the numerator times the numerator and the denominator times the denominator. That would give us an answer of 15/4. Now we know as well that we can change that fraction. That's a top-heavy fraction. We can change that improper fraction, we can also call it, to a mixed number fraction, which is 3 3/4. And that's it for today's lesson. You've got your arithmetic task assigned on Teams. Now, I've attached a link to a video that I did with year 5s actually, to go over some of the other arithmetic skills if you want to have a little bit of extra support. So there's a bit of a recap in that video of some arithmetic questions. You're more than welcome to use that. Good luck with the tasks. As ever, really look forward to seeing your work on Teams. Keep up all the hard work. Been so impressed with what I've seen this week. And my arm's getting tired now, so I will see you next week.